Okay, so this is video number 2 using dimensional analysis with dosage calculation. Now this is going to be kind of a mixed method type approach. You can definitely from beginning to end use dimensional analysis. This is another one of these pieces where it's just a little bit easier to break things down a little bit before we dive into start doing the dimensional analysis. So in these type of problems are a little bit easier to identify whenever we start looking at figuring in weight-based orders or dosages. And you're usually going to see something like this setup right here. On this one, it says 50 milligrams per kilograms per day. It might say X milligrams per kilograms per dose. It might say X milligrams per pound per day, but they're pretty easy to identify. And so whenever we see this, we know that we've got a little bit of work that we can put in to make this whole process a little bit easier if we do some things before we get started. So just looking at the problem, the order for a patient weighing 10.4 kilograms is 50 milligrams per kilogram per day to be given Q6 hours. The label for this medication states that there is 125 milligrams per 5 mils. So in part A of the question, we're going to find out how many milligrams will the nurse administer per dose, and then how many mils will the nurse administer per dose. Okay, so especially whenever we see this, we want to pay close attention to what the question's asking, because we see that this is different. Even whenever we solve this portion to say okay, how many milligrams we're going to give, it's in per day, so it's not in per dose yet. So that means that we're going to have to come over here and do a little extra work. So let's figure some things out first. 1, kilograms and kilograms. So the weight that we have for this patient is already in kilograms, so we don't need to do any conversions there. And what this problem is saying is that for every 1 kilogram of weight, we're going to be giving 50 milligrams of medication. Okay, so that's really just a simple multiplication problem. It's even more simple since it's already in kilograms. So if we calculate how many milligrams per kilograms, how many milligrams we're going to give, so we go 50 times 10.4, and that equals 520 milligrams per day. Okay, so we can cross that out. And so this is our new information here for the problem. That's our order, to be given every 6 hours. So how many milligrams will the nurse administer per dose? Well, this tells us per day, and we see that we give it every 6 hours. Now, one mistake that students make is that they take 520 and they divide it by 6, but that's not right. What this is saying is that we are going to give medicine every 6 hours, and there's 24 hours in a day. And so we're dividing that 24-hour day into 6-hour chunks, which means there are 4 doses in a day. And so from that point, all we have to do is divide 520 by 4, and that gives us 130 milligrams per dose, which essentially answers our question right here. 130 milligrams per dose. And then now this is asking how many mils will the nurse administer per dose? Well, this is just like the problems that we did before in video number 1. Okay, we have our order, which is 130 milligrams per dose, and now we want to know how many mils, and we can go back and look at our problem and see that this is what we have available. So let's go ahead and solve that problem just the same way that we did before. We're working towards mils, so we're going to put mils on top. And we see here in our problem what we have available. For every 5 mils of liquid, there is 125 milligrams of medication. Now I need to get rid of the milligrams, and this is where we can pull in our order that we have here, 130 milligrams. Those cancel, and I'm left with just mils on top. And so now we can start multiplying across. So we've got 130 times 5 equals 650 divided by 125. That equals 5.2 mils. And we'll just leave it like that. Usually the question will specify round to the nearest whole number or whatever. And if we look at this makes sense. This number, this amount makes sense because for every 5 mils, there's 125 milligrams of medicine, and our order is for 130, which is just a little bit over 125. So that makes sense that 5.2 mils would equal 130 milligrams. Always make sure that you're kind of making sure that your answer makes sense. Okay, number 2. The doctor's order is for amoxil 30 milligrams per kilogram per day, available as amoxil 250 milligrams per 5 ml solution. We're going to calculate the Q 8-hour dosage of amoxicillin suspension for a child weighing 41.5 pounds, and we're going to find out how many mils will you administer per dose. Okay, so we see that this is a weight-based problem. So let's go ahead and start looking at a few things. So kilograms is what this order is in, but our weight is in pounds. So let's go ahead right now and take care of this number. Let's get that into kilograms. So working towards kilograms, I know there's 1 kilogram per 2.2 pounds. And then this is where I can pull in the 41.5 pounds. So that I can cancel those pounds. That cancels. All I'm left with is a kilograms on top. I can throw that over 1. And now I can solve the problem. 41.5 divided by 2.2. That is 18.863. It goes on and on. So I'm going to come over here. This is now, let's round it to the nearest tenth, so we're going to say 18.9 kilograms. So now we can look at this problem and figure out what the dosage is for the day. So for every 1 kilogram of weight, we're going to give 30 milligrams of medicine. So we're going to multiply that times 30. Now, if you rounded first here and you went 18.9 and then you multiplied times 30, your number is going to be a little bit different than if you left the 18.863 on and on that was on your calculator, you left it and then multiplied times 30. It's going to be a little bit different, and that's okay. I usually try to wait until the very end to round, to do my rounding. So this was 565.90, and then that repeats. And that is milligrams per day. Now, if we're looking at this first part of the problem, it's not wanting to know the per day dose. It wants to know the Q 8-hour dose, right? So that means that we're dividing the day, 24 hours, by 8, which means we're going to give 3 doses, which means that this is going to be divided by 3 so that we can get our per dose. Again, I still have that long decimal number on my calculator, and I'm going to hit divide by 3. That equals 188.63, and then that continues on. Milligrams per dose. Now this is the point, since this is the answer to A, we can go ahead and round. So 189 milligrams per dose. And just pay attention to if it gives you specifically what it wants you to round to, and make sure that you are rounding appropriately. You don't want to go to the work and do all that math great and then miss it because you didn't round to what it wanted you to. So now for B, how many mils will you administer per dose? This is just like the other problems that we have been solving. So we're going to go, we were working towards mils. Put that on top. This is what I have available here, and we can pull that in, 5 mils. There's 250 milligrams. I need to get rid of the milligrams, so now I can pull in my order. And that's what it's wanting, the per dose. So that matches up, that's the right one. So 189 milligrams. That cancels, so we're good. So 5 times 189 equals 945 divided by 250 is 3.78 mils. Now you're usually not going to measure out to the 0.78 mils. Let's just go ahead and round it to 3.7 mils. All right. Number 3. The dosage of 125 milligrams q6 hours of prostophin has been ordered for a 21-pound child. Available is prostophin 250 milligrams per 5 ml oral solution. What is the per day dosage? And if the safe range for this medication is 50 to 100 milligrams per day, is this order within safe range? So, looking at the problems, 125 milligrams every 6 hours has been ordered for the 21-pound child. Now, this is a little tricky because you say, okay, I've got this order. We've been doing these weight-based problems. So it's kind of tripping you up a little, but the work's already been done. This is just your order. 125 milligrams, q6 hours. That means every 6 hours you're giving 125 milligrams. So that is your per dose ordered there. And then this is our available. Okay, let's see what it's asking. We want the per day dosage. And again, this is a tricky spot for students because before we were dividing and doing that work. So we've really got to pay attention to what exactly is the question asking. So this says that we are giving 125 milligrams every 6 hours. So that doesn't mean we're giving 6 doses. That means that we're dividing the day into 6-hour chunks, which is 4 doses. And so this is kind of the reverse of what we were doing in the previous 2 questions, is we're going from a doses, how many doses to, the amount that we give per dose to the amount that we give per day. So that means that we're going to multiply 125 milligrams times 4 because we're going to give it 4 times in a day. That equals 500 milligrams per day. Now, the second part of the question, if the safe range for the medication is 50 to 100 milligrams per day, is this order within safe range? So it's asking, so if that's what the safe range is, we've got to take a look. Is our order, is that within this range? Is it between 50 and 100? Well, no, 500 is way over here somewhere, right? So that is not within the safe range, so no. Number 4, the doctor has ordered 100 milligrams per kilogram per day QID for a child weighing 20 pounds. Available is Principin 250 milligrams per 5 mils. How many milligrams will the nurse give per dose? And then how many mils will the nurse give per dose? Forgot an L there. Okay, so if we look, first thing that we're seeing here, we've got our weight-based problem here, and it's in kilograms. Our child is in pounds. Let's go ahead and get this converted. So we know that there's 1 kilogram, we're at 2.2 pounds. We're going to pull in our 20 pounds so that we can cancel. So 20 divided by 2.2 equals 9.09, and then that continues on. Okay, so that's what goes here. We're going to multiply that times 100, because remember, for every 1 kilogram of weight, we're going to give 100 milligrams of medication. Then we can just, with our hundreds, for however many zeros we have there, we can move that, whenever we're multiplying, we can move that over twice. So that's 909 milligrams per day, right? All right, so we've done a little bit of work there to help make this a little bit easier. How many milligrams will the nurse give per dose? All right, so let's look at this. Says so we need to know the frequency. How often are we going to give this medication? It says right here we're giving it QID. That means we're giving it 4 times a day. Now we don't need to divide up our hours because it's not talking in hours, it's talking in doses, and we're going to give it 4 times per day. So that's don't let that trip you up, and really pay close attention to the wording of the problem. Okay, so that means that we're going to divide 909 by 4 into 4 doses. 227.27, and then that continues on. To answer this question, we're going to go ahead and round that. How many milligrams will the nurse give? Let's say we want to round it to the nearest whole number, so let's say 227 milligrams per dose. All right. How many mils will mils will the nurse administer per dose? All right. Now this is back to our how we were doing the problems in the first video. So we're working towards mils. Put the mils on top. Then we see right here, $250 milligrams for every 5 mils of liquid. So let's go ahead and put our 5 mils, 250 milligrams. And that's where we're going to pull in this because it's per dose that we're working towards. So we're going to use our per dose order. So we can plug in 227 milligrams. That cancels. So we are good to start multiplying across. 227 times 5 equals 1,135 divided by 250 equals 4.54. For this one, per mil, that makes sense too, right? Because 227 is just under 250. And for every 250, so 5 mils, that's 250 milligrams. So just under 5 mils makes sense, right? So let's go ahead and do that to the 10th place. Let's say we're going to give 4.5 mils